Okay, so this is the first video for lesson 1.2. There will be two parts to this, and there will be two videos as well. Okay, so we're going to start talking about properties of numbers or reviewing properties of numbers. And first, we're going to take a look at the commutative and associative properties of addition and multiplication. And basically, these properties allow us to rewrite addition and multiplication problems in different orders than what we are normally given. So, the first thing we're going to do here in exercise 1 is simply identify each numerical expression below by its property. So, this is kind of a little bit of a review. So, if you remember, the commutative property of addition or multiplication is where you switch the order. And the associative property of addition or multiplication is where you switch the groupings or the parentheses. Okay, so looking at our first example, 5 plus 7 equals 7 plus 5. Well, what changed? The only thing that changed was the order. So this would be the commutative property of addition. Okay. When we look at the next one, again, look at what changed. Now, the first thing I always look at is the order. On the left side of the equal sign, it goes X, Y to Z. And on the right hand, it goes X, Y to Z. So since the order of the variables did not change, it can't be a commutative. However, what did change is the parentheses. They moved from y plus 2z to x plus y. So this would be the associative property of addition. Okay. For our next example, again, you want to say to yourself, all right, change. Now, I purposely put this one in because a lot of times when people see parentheses and like addition like that, they assume that that means it's associative. And not the case, or not so in this case. A plus B is still in parentheses. What changed is the order of the multiplication. So we went from 4 times A plus B to A plus B times 4. So this would also be commutative property, but this is of multiplication. Okay. Whereas if you look at the final problem, okay, again, look at the order. 6GH on the left, 6GH on the right. What's changed are the parentheses. So this is your associative property of multiplication. Okay. So exercise 2 asks for an example that shows that subtraction is not commutative. So I want you to think about that for a minute. Just think of any problem that would show that subtraction is not commutative. If you want to pause, go ahead. But this is the problem or the example that I'm going to use. 5 minus 3 is equal to 2, but 3 minus 5 is equal to negative 2. So therefore, 5 minus 3 does not equal 3 minus 5. So it's not commutative. The same thing is true with division. Okay, it didn't ask for it, but 10 divided by 5 is 2, but 5 divided by 10 is 1/2. They're not the same. Okay, probably one of the properties that we use the most is the distributive property. Okay, and this typically involves addition, and with addition also goes subtraction. If you think of addition as, or subtraction as the addition of negatives, and multiplication. So it says, express the following products as binomial expressions. So this is a term you probably heard last year. But if you think of the prefix by, that means 2. So that simply means that all of our answers are going to have 2 terms to them. So when we do the distributive property, we are taking what's on the outside of the parentheses, okay? And for our purposes right now, it's going to be a number, and we're multiplying it to everything on the inside. Now, where it says show each step of your calculation, that would be something like this. We're going to do 5 times 2x. There's a plus, so plus 5 times 3. And now we multiply. So we're literally just multiplying the big numbers, as I call them. We're not worrying about exponents right now. So 5 times 2x is 10x. 5 times 3 is 15. There is our binomial. Okay, you cannot add 10x and 15, so we just leave it 2 terms. So for B, we'd have negative 4 times 5x. Now we have minus 4 times negative 8. Whatever sign is in the front, bring that with it. And then whatever sign is in the middle has to be there too. So negative 4 times 5x is negative 20x. Negative 4 times negative 8 is positive 32. Okay. Now, the other way that you could do this, and maybe some of you already have started to do this, is instead of writing out, 5 times 2x, 5 times 3, you can just kind of use arrows. Technically, you don't even need to do that, but it's a good way to remember that you're not just multiplying what's on the outside by the first term. You're multiplying by both. So 3 times 4x is 12x. 3 times 9y is plus 27y. So if you want to try D, you can pause it. 5 times x is 5x. 5 times negative 7y is minus 35y. Okay. I'm going to throw in a problem that's not listed here. So this will be secret problem E. Let's say we had negative, what number haven't I used? All of them. So let's say we had negative 10a minus b, and we'll keep it like that, 10a minus b. Okay? We are still going to use the distributive property. What's really with that negative out front? We just don't write it. It's really a negative 1. Okay? So even when it's just a negative, you're still distributing a negative 1. So negative 1 times 10a would be negative 10a, and negative 1 times negative 1b would be positive 1b. Now you can write the 1 in front of the b, but you do not have to. Okay, and the last part of this part of the video is still using the distributive property, but this time we're going to work with division. So remember, the commutative property does not work for division, but distribution property or distributive property will. So again, express each of the following quotients. Remember, quotient is a fancy word for division problem, as binomials, 2 terms in simplest form. Some of your final answers will contain fractional coefficients, and that's fine. So basically, if you think about what we did up here, say with C, we took the 3 that was being multiplied and we multiplied it by 4x, then we multiplied it by 9y, or actually one of these examples up here. We're going to do the same thing with division. We are going to distribute the 2 that's being divided. So we're going to do 8x over 2 plus 4 over 2. And now divide. Well, 8 divided by 2 is 4, so 4x. 4 divided by 2 is 2. So there's our binomial. For B, 25x divided by 5 minus 50 divided by 5. So 25x divided by 5 is 5x. 50 divided by 5 is 10. Right? Now I realize maybe you don't have to separate them out in order to do the division, but examples C and D are going to show you why you should, okay? And that's because we're going to get some fractions. So for C, 2 is not divisible by 4, and we don't want decimals here, okay? There's nothing wrong with decimals. However, a lot of times when we're working with fractions, we don't want to mix decimals in there. Also, if you're dealing with a multiple choice problem, chances are it'll have a fraction. So in this case, we have 2x over 4. We just want to focus on the 2 over 4. Now, if you put 2 divided by 4 in the calculator, you will get 0.5, but we want it as a fraction. Now, there's a couple ways that we can write this. We can write this as 1x over 2. We can write it as x over 2 because you don't have to write the 1. Another way that you might see it written is 1/2 x. Now, where does that come from? Well, that comes from the fact that this right here can be rewritten as 2 over 4x. The x doesn't have to be up with the 2. It can't be down with the 4, but it doesn't have to be up with the 2. It can be, the 2/4 can kind of be floating like outside. So you would reduce the 2/4 to 1/2 and then have the x. Either way is fine with me. Okay? Minus, and now 16 divided by 4 is 4. So now we're going to do the same thing over here. Okay. Now, while ideally you should be able to reduce fractions, we do want to make sure they are in simplest form. So again, this is where your calculator is really going to be a big help. And you want to make sure you use your fraction button. If I do -9 divided by 12, I get a decimal. Okay, I don't want a decimal. Now, I can make that into a fraction by hitting math, and then the first choice is frac. So I just hit enter, and it'll make it a fraction. I mean, that's totally fine. Me personally, I just really like to get in the habit of using the fraction button. So -9 over 12, and it reduces it to -3/4. So again, because we have that x, we can write it as -3x over 4, or we could have written it like we had over here and done -3/4 times x. It does not matter. Okay, and now we want to simplify 18/12. And we get 3/2. So plus 3/2. Okay. All right. So now you're going to do the couple or the few practice problems I assigned, and then jump right into the next video for 1.2b.